Thanks for joining us. Today we will be discussing the importance of measuring forces at the wheel-rail interface, how wheel impact load detection was developed to achieve this, and an overview of L.B. Foster's Wild 4 technology. First, the impact that Wild technology has had on the industry will be illustrated, and its many applications will be discussed. Next, we will describe the benefits of utilizing strain gauge technology to measure wheel impacts. Presenting today is Jacob Capra, Product Manager of Wild Systems. Jacob has spent 10 years at L.B. Foster with previous roles in engineering and sales across multiple departments. Now I'll hand it over to Jacob.
Thank you, Meredith. And apologies for anybody that may have tried to attend this Democast last week. You might have seen in an email we had some technical issues with the platform. So sorry again, and thank you that you're able to tune in today. Like Meredith said, I'm Jacob Capra, if we haven't met. I'm Product Manager of Wild Systems at L.B. Foster. Thanks for joining us today. I'm happy to share a little bit about Wild technology, the importance it has in the rail industry, and how it came to be. So today, like I said, the focus is Wild technology, that's wheel impact load detection. But why exactly are we interested in wheel impacts? Well, wheel-rail interaction forces are a key consideration for any railroad. Hazardous conditions like wheel defects, improper loading, and damaged rail, all of which can lead to derailment. But also, repeated high impacts can lead to damage or premature failure of track infrastructure. So, in order to prevent all of this, wheel-rail forces are heavily used as a diagnostic tool for monitoring wheel health, loading conditions, and general track stability and integrity. I'd like to briefly talk about the history and the inception of wheel impact load detection as a technology. Now, the problem that led to the development of Wild technology was early signs of rail seat cracking on portions of 400 track miles of concrete tie track installed on Amtrak's Boston to Washington line. These rail seat cracks were first detected in June of 1980 during a program being conducted to correlate the performance of these concrete ties in revenue service with the performance of the same ties at a facility called Facility for Accelerated Service Testing. Now, as part of this research program, it was determined that these cracks were being caused by high vertical loads being generated by wheel tread irregularities on Amtrak's passenger coaches. Investigations revealed that out-of-round conditions were identified as the culprit, causing the most severe vertical loads, sometimes exceeding 100,000 pounds. But more importantly, these wheels were very difficult to detect through typical inspections, usually visual. And in fact, they often would pass existing geometry wheel condemning limits that Amtrak had in place. So as a result of these findings, Amtrak and the FRA undertook a program to have Battelle's Columbus Labs develop and install a permanent monitoring device to detect wheels which produce excessive loads. The result was the first wheel impact load detector, which was built and installed in the summer of 1983. Soon after, a lead engineer on the project from Columbus Labs, his name was Harold Harrison, he patented this technology and formed his own corporation, which today is known as Salient Systems. Since that time, Salient has spent the last 40 years making continuous improvements to Wild technology and providing support for its use in the industry. Since its invention, over 200 Wild systems have been installed in the US, with many more across North America and all across the globe. By using these systems for targeted removal or maintenance of high-impact wheels, the industry has experienced a significant reduction in overall derailments. A report published by the FRA in 2019 showed that in a 10-year period, the number of Wild detectors in the industry increased from 54 to 168. And in that same time span, track-related derailments decreased from 155 to 73. a reduction of over 50%. Now, looking at the top 10 track-related causes of derailments, those decreased from 93 down to 32, a reduction of over 65%. This data set shows a great correlation, but it ends in 2012. However, the FRA's Office of Safety Analysis reports all derailment data, and this allows us an opportunity for a larger look. Looking at a data set that extends this same information to 2020, we see a continued decrease in relevant derailments. In fact, all track-related derailments are now down by over 58%. And what this illustrates is that while there was a large uptick in wilds in the 2000s and 2010s, and they correlated with a significant decrease in derailments, we can see that in recent years, the incremental increases in wild in the industry have continued to enhance safety. So we can expect that deploying wilds can reduce derailments, but what impact financially does this really offer to the industry? Well, a review of that same FRA derailment data shows that in the last 20 years, when adjusted to $2025, the direct cost to agencies per derailment averages about $432,000. By reducing track derailments by some 50 to 60%, the industry has saved between $33 million and $40 million a year in direct costs. But that's not the full story. We know that there's significant savings in indirect costs like lost revenue and reductions in operating efficiency as well. In fact, the wild has proven so reliable for detecting wheel defects that the AAR's Wobble Committee has specified regulations so that wilds can qualify for users to set out and replace high-impact wheel sets, even if the user is not the car owner. So long as a wild has been calibrated in the last 3 years and at least 70% of the sensor's circuits are functional, data from that wild can be used to authorize wheel set replacement, which results in a bill back to the car owner. Not only does this provide a source of revenue for wild users, but removing high-impact wheels from the user's networks ensures that their track infrastructure isn't getting damaged. With that said, wild systems have many additional benefits and applications aside from preventing derailments and identifying wheel defects. Reducing high impacts, like I mentioned earlier, can reduce rail fatigue, tie damage, and bearing damage, but it also improves wheel tread lifespan. In fact, in transit applications, we've seen that using wilds can extend the wheel set lifespan by 20% or more. And at the same time, it can reduce noise and vibration in passenger vehicles by catching defects that impact ride quality early on. Identifying overload and imbalance can help short lines and industrial railroads avoid punitive charges from Class 1s associated with non-compliant loading during interchange activities. So the point is, regardless of the rail sector, the wild technology has proven to provide pretty immense value to its users. Next, I'd like to talk a little bit about L.B. Foster's wild offering, which is called the Wild 4. The Wild 4 uses a large array of strain gauges to measure forces imparted onto the rail from the wheel. Both vertical and lateral forces are measured, as well as many operational variables like vehicle speed and direction, vehicle weight, and weight distribution. The collection of this data is carried out 16 times per wheel for each train pass, ensuring a complete and high-quality capture of the load from each wheel. The data is digitized, filtered, and analyzed directly on the rail via rail-mounted front-end processors, ensuring that there's no transmission loss or electromagnetic interference. Alongside the sensors and other trackside equipment, the Wild 4 includes a control cabinet, usually located in a nearby bungalow or equipment building. The control cabinet handles all power distribution, control, logic, and communications to the Wild system. Wilds are also usually paired with an AEI tag reader assembly, which automatically assigns measured impacts with the corresponding car wheel set. Ancillary equipment like radio talkers, which are used to immediately alert train operators when excessive impacts are measured, are simple to implement using serial ports right in the control cabinet. Data collected by the Wild can be sent directly to customers or to L.B. Foster's Custom Wheel Data Management System, or WDMS. Using WDMS, users can set and manage multiple alarm thresholds for many preset parameters, or build their own custom criteria. They can manage personnel that receive alerts, review all historical data for consists or individual trains, axles, and wheels, and conduct statistical analysis on all of their wilds and their entire network in a single place. The last component of the ring is field service. L.B. Foster has a dedicated wild field service team that provides site surveys for potential new sites and offers functional insight and recommendations. They also handle 100% of system installation. They're available for calibration, repairs, maintenance, and in-the-field diagnostics. Now, if you're a wild owner and you're experiencing issues, Salient has a dedicated customer service team that's available via phone or email at any time. They can also provide support for things like system diagnostics, data analysis and interpretation, spare parts supply, and software troubleshooting. Now, there are many emerging technologies for force measurement, generally speaking, but also in the rail industry. And a common question that I get is strain gauges. First and foremost, strain gauges remain one of the most accurate and precise force measurement sensors on the market. There's a reason why they continue to be used in high precision information critical applications, things like pharmaceutical scales and stress monitoring of heavy equipment. They're also, with many of Salient's strain gauges exceeding 15 years in the field, they do need to be replaced, and implementation is generally non-intrusive. Strain gauges can be sampled at any frequency, ensuring that critical information is never left out. They can also be configured in countless ways, making them ideal for force measurement in any direction. Now, these configurations allow wilds that use strain gauges to measure only the stresses and forces that users are interested in and ignore everything else. So sampling rate should be a key consideration when collecting any data, but this is particularly true in the rail industry. At typical track speeds, a train wheel will pass from one tie to the next in less than 25 milliseconds. It's crucial that in this short span of time, enough data points are captured to accurately describe the load throughout the grid. With too few data points, you lose critical information about the shape and characteristics of the load profile, but more importantly, you run the risk of undersampling or clipping the true peak, which will lead to underreporting of peak loads. By investigating a real peak captured by a wild force system, we can see what reducing sampling rates does to reported loads. Very high sampling rates provide an excellent load profile through the grid. You can see in the graph above, 12,500 hertz provides an excellent profile. But reducing the sampling rate to 10,000 hertz or even 5,000 hertz has virtually no effect on the shape and characteristics of the load profile or the reported peak load. However, as we continue to reduce the sampling rate, we see that the shape of the load profile starts to become less defined and that the peak begins to get clipped. Sampling rates lower than 2,000 hertz can be shown to reduce the reported peak load by anywhere from 2 to 10%, while rates below 1,000 hertz can lead to significant underreporting by more than 20%. Now, another key benefit of strain gauges, particularly in rail, is the ability to ignore stresses that are not directly related to the wheel load. What we're primarily interested in is the vertical impacts indicative of wheel defects, but rail stress is much more sophisticated. In reality, vertical loads are often not applied at the center line of the rail, and there's also lateral loads being applied at the gauge point by the wheel flange. These two loads also induce bending of the rail in multiple directions. And on top of that, there are compressive stresses acting on the foot of the rail due to reactive forces from the tie and the rail fasteners. So it's critical that a wild system factors all the ways that the rail is stressed and has a method to determine which stresses are from vertical loads and which aren't. Now, strain gauges are ideal for this application because they can be placed in critical locations within the web of the rail and along the neutral axis. This placement allows for measurement of pure shear, which is directly related to the vertical load, while ignoring other sources of stress that are not of interest. And with that said, hazardous conditions can arise from various forces exerted on the rail besides vertical impacts. High lateral loads are indicative of gauge narrowing, flange wear, and truck hunting. The same principles that isolate stress from vertical impacts can be applied for lateral impacts as well, achieved with the Wild 4 through installation of gauges on the foot of the rail. This allows the Wild 4 to simultaneously monitor for critical impacts both vertically and laterally, and identify sophisticated loading that can be indicative of still more hazardous conditions, such as wheel climb. So we've been discussing sources of inaccuracy that could be present in a wild system. And I'd like to consider a wild system that, because of sampling rates, may underreport peak loads by 5%, like we saw a few slides back. Now, a review of a Class 1 wild network revealed that in a matter of only 5 days, there were almost 250 wheels that measured 5% or less over the 90 kip threshold that authorizes wheel set replacements. That's to say that there were almost 250 wheels that measured between 90 and about 95,000 pounds. Based on car owner codes and how far each measured impact was from the 90 kip threshold, an estimated 19 billback opportunities for wheel set replacement would have incorrectly measured below 90 kips due to that underreporting of the peak load. And that's in only 5 days. At current billback rates, that equates to over $800,000 in lost profit every single year. And that number could actually be significantly higher depending on who actually owns the cars. However, underreporting isn't the only inaccuracy that is going to impact railroads. Consider instead a wild system that overreports by 5%, maybe due to lower accuracy sensors or by measuring stress that's not related to vertical impacts. In the last 3 months, that same Class 1 agency has seen 20 wheels that have measured 5% under the 140 kip threshold that requires an immediate set out according to AAR guidelines. Now again, based on each wheel's individual measurements, an estimated 9 wheels would have incorrectly measured at over 140 kips in that 3-month span and been incorrectly set out. Over a year, this would equate to at least 36 premature setouts, which will result in a significant reduction in operating efficiency. So I want to summarize. Why does the industry use wheel impact load detectors? Well, whether it's a Class 1, a regional or short line, or a passenger system, the Wild remains a critical solution for the rail industry. It enhances safety, it can improve efficiency, it extends the lifespan of your assets, protects your track infrastructure, and helps you avoid costly maintenance and charges. That's all I had. Thank you again for tuning in today. And if there are any questions, I'm happy to answer them now.
Thanks, Jacob. It looks like we did get a couple questions in the chat. The first one is asking, what if I need to replace the rail or perform maintenance on the track the Wild is installed on? Does the Wild need to be calibrated on a regular basis?
Sorry, can you repeat that?
Oh, sorry. Yeah. What if I need to replace the rail or perform maintenance on the track the Wild is installed on? Does the Wild need to be calibrated on a regular basis?
Let me take those in order. If the rail needs to be replaced, that will require generally what we call a rebuild of a Wild or a disconnect, reconnect. So some of the components that are installed on track are permanent, mainly the gauges, and they're destroyed when they're removed. but a lot of the components can be safely taken off. So LB Foster would send a field team to support that, help you remove the components that can be salvaged, and then reinstall them once the rail is replaced. Now, if there's general maintenance that's needed, let's say sort of something like tamping or surfacing, all of the equipment that is on track, as you can see in the photo here, actually tucks under the head of the rail. So it's generally safe. I know some tamper systems do grab there. We would recommend using a tamper system that grabs from the foot of the rail. Another consideration when you're doing maintenance or using vehicles in the right of way is the cabling. The Wild 4 has just 2 cables per rail, and they actually connect to the track with quick connect fittings, so they can be quickly just disconnected and pulled off to the side of the right of way so that you can bring in your maintenance machines or take a truck down the right of way and do your maintenance. I'm sorry, and then there was one last bit of that. How often should they be calibrated? It's really up to the user. We've seen some systems that there are some systems 12 years in the field, never been calibrated, still functioning. But if you plan to use this system for billbacks, the AAR does require that it's calibrated every 3 years, and that's our general recommendation as well. Sorry, continue.
Okay, next question. Is the installation process of the LB Foster Wild system invasive to the rail? If rail had to be replaced, would entire system have to be replaced?
So that was sort of answered in the last one. The gauges would have to be replaced, but that's the only equipment on track that would need to be replaced during a rail replacement. Whether it's invasive to the rail, I would say no, generally speaking. The only thing we generally do to the rail is grind it, which you can see somewhat in the photos. And then there are periodically holes drilled through the web of the rail in certain cribs. And they're 3/8 of an inch in diameter right in the center, so quite small.
Okay. What are advantages of strain gauge wilds versus accelerometer based wilds, which is recommended for a heavy commuter transit system?
Well, I think in any application, I would recommend a strain gauge based wild, speaking completely non-biased, of course. But I think the issue with using something like an accelerometer is that there are more steps from the physical phenomena that's being measured to what you're interested in, which in this case would be an impact, right? Whereas with a strain gauge, and in our situation, we measure pure shear, and the shear stress in the rail is directly related to the force. So they're completely proportional. Accelerometers can be affected by a number of things. The track stiffness will affect that, of course. Any suspension action from the vehicle. You might have some sort of dampening going on, whether it's rail seat pads or ballast mats, things like that. And that can all affect the acceleration that this accelerometer would see and ultimately what it would report out.
Okay, thank you. What is the difference between strain gauge and accelerometer based wild systems?
Well, I would, that I guess, was somewhat covered there. An accelerometer, right, is going to measure acceleration of the rail, usually right at a tie or, maybe in the crib to estimate the force that was imparted on the rail. Now, there's a lot of value in knowing the acceleration of your ties, essentially the movement of your ties as a train passes. It's just maybe not the best way to determine the impact that a wheel imparts on the rail. The model that you would have to create for all of the interactions between the earth, the ballast, ties, any dampening systems like pads and ballast mats, the rail itself, and then the unsprung and sprung mass of the vehicles, it becomes a very sophisticated system. So using acceleration to determine force can get extremely complicated. That's why we try to elect to use a relatively simple system and measure something as closely related to the actual force as possible.
Thank you.
Meredith, did I lose you?
This question is, how is the wild strip affixed to the rail web, how long does it typically take to install it on one?
Sorry, you were breaking up just a
Sorry
little.
about that. Can you hear me?
Yeah, that sounds better.
Jake? Oh, okay. Yep. Can you hear me now? Okay.
Yes.
How is the wild 4 strip affixed to the rail web, and how long does it typically take to install it on one track?
So installation of components are different depending on the type of component. The gauges, for instance, are welded. The circuit boards and the processors are adhered and clipped. And then you could see the clips actually on the processor there, the black box in the photo. And then the guards, which protect all of the circuitry, are also clipped onto the rail. So generally a pretty quick process to actually affix everything with the exception of the gauges. How long does it take per track? It depends a little bit on the status of the track when we arrive and how well it's been prepared. But generally, you can do. We don't typically do them rail by rail, but both rails relatively simultaneously. You can do both tracks in anywhere between 3 to 5 days, depending on the conditions. So installation of a full system is usually 3 to 5 days.
Okay, thank you. What is the variance of wild detectors when measuring gross weight? As a shipper, we often see a discrepancy between reported wild readings and our origin scale weights.
Great question. This one, it's a sophisticated answer because the vehicle weight and our accuracy when reporting vehicle weight depends heavily on two things: vehicle speed and track stability. So what we see is that on very stiff track at low speeds, we're very accurate, within 1%. If the vehicle is at track speeds, then it's more like 2 to 3, maybe even 5% off. It depends. And then if the track infrastructure is either soft or maybe in need of maintenance, then that number can vary even more. So it really depends. But I would say a general rule of thumb is that we're about 2 to 3% from true weight. But with that said, we have endeavors to create a more accurate wild for measuring vehicle weights.
Thank you. Does LB Foster do any demos of Wild 4 in conjunction with railroads?
We have done some in the past, and we also have a demo version that we bring to trade shows. Of course, it's not actually loaded with a train, but the interesting thing is you can press on the rail with your finger, and the wild will see that and report it. So it is functioning. It just doesn't see a large load. But with that said, we have very good working relationships with a number of agencies, and have in the past been able to take people that are interested in seeing how a wild works and maybe having a wild, take them out to another owner and just kind of let them see how it operates and what it looks like on track. So yeah, we can do things like that.
Thank you. Is there more need or interest in a wild installation along curved sections of the track or in areas of steeper incline or decline of the track?
I think more so for the former there, in curves. We generally recommend tangent track for wilds because we want uniform loading between the rails, to put it simply. But with that said, we are starting to believe that we could identify some new defects much more effectively, some less common defects more effectively if we were measuring in the curve, just mainly due to the type of contact that we're getting at the flange and the transition from the flange to the tread on the railhead. It's normally variable when you're in tangent track, but gets obviously really good in a curve. So if we wanted to monitor better for defects in that area, then we would, yes, investigate installing in a curve. But there's some development work that would have to be done there.
Okay, thank you. Can Wild 4 be installed on any type of track tie type, hardwood, steel, concrete, direct fixation?
Yes, the only support type that I would say that you couldn't install on is anything that doesn't allow bending of the rail, right? So basically, a fully supported, like you might see on an approach to a railway track scale, that would not be suitable. But anything that supports the rail intermittently and allows for basically a crib, yes, you can install the Wild on that. Now, we have installations mostly on concrete ties, but also on wood ties. We're very interested in installing a Wild on direct fixation. And there's nothing inherent in the design that prevents us from doing that. Spacing for direct fixation fasteners is typically a little longer than we install on concrete ties, but with some different length cables, that would be, that issue put to bed. So yes, you can install on pretty well any fastening system.
Thanks, Jacob. What is the standard interval of Wild installations along a track line? Are there any regulatory tailwind to tighten the intervals required?
That's another great question. Right now, there are, first of all, no requirements, regulations, I should say, on how often or when or where a Wild should be or needs to be installed. It's completely up to the owners. What we have learned from speaking with various users is that rather than doing it on a mileage, or something like that, as you would see with HBDs, it's commonly spaced to maximize fleet coverage, right? So if you've got, a dedicated line that's got 10% of your fleet, you could put a Wild on it and capture all 10 of that, right? So they're positioned strategically along the network to capture as much of the fleet that currently sees no Wild. And generally the metric is some sort of percentage of your fleet being seen every 2 weeks or 4 weeks by a Wild is the target and the motivation to, first of all, install a new Wild, and then where to install a new Wild.
Okay. Would Wild strain gauge replacement incur a mobilization fee each time the crew was needed?
Generally speaking, yes, there are some customers that are able to do these things on their own, but the strain gauges are quite difficult to install. And so we don't recommend users removing and reinstalling gauges. We recommend doing it, having L.B. Foster's field service team do it. So yes, but it's not very common that gauges are removed and reinstalled. We support calibration services, and the typical, periodicity with this is that when we visit a Wild site every 3 years to do a calibration, we will also check to see if any gauges need to be installed, rather replaced. And while the team is already there for recalibration, we would do any maintenance like replacing a gauge.
How quickly would teams mobilize in an event of unforeseen track conditions such as broken rails?
That's a tough question. I would like for it to be ASAP, and many times it can be within a day or within a couple days, depending on how far away they are. But there are times where the entire field service team is out of state, far away, maybe even out of the country, and so it really depends on the schedule of the field service team. But there have been many situations in recent years where we have been out within a day or two, and have been able to support, getting a Wild back up and running and reporting to RailLink or what have you, as quickly as possible.
How would the affected wheel sets be identified? RFID? Does this Wild system work with TransCore RFID readers?
That's exactly right. Yeah, we use tag readers to assign the impacts to cars, and then by knowing the car type and how many axles, we can assign each impact to individual wheel sets. And the system does work with the TransCore E4 systems, yes.
For the on-site Wild 4 demos that L.B. Foster has conducted in the past in conjunction with railroads, has L.B. Foster considered inviting the media and government officials such as planning department and engineering department directors, transportation and urban planners, etc.?
We haven't, but that's an interesting thought. Most of these have been in the private sector. And in fact, most Wilds are owned privately. not through public agencies. So there's very little state and local and federal government oversight and also insight into the use and the need for wild systems. But that's not necessarily a good thing. And so, uh, it might behoove us to see if there is an interest for, government representation at these sorts of things. I'm not exactly sure how that would go over with those allowing us to, come and see other wild works, but certainly an interesting thought.
Okay, during a flood event, how does the wild system hold up? Would the entire system need to be replaced?
No, most of the equipment on track is IP67 and should survive a flooding event. Depends on obviously how long it is. And then a lot of the critical components are electrical components are also potted. You probably will see some damage, but it certainly wouldn't completely destroy the system. Now, that's all subject to the severity of the flooding event, of course. I mean, catastrophic things can happen, and it could knock the wild out entirely. But this is my 6th year with Salient Systems, and I have yet to hear of a wild system being affected by a flooding event.
Thank you. Okay, the AAR sets thresholds, example 90 KIPS, but the Class 1 set their own thresholds for reporting to their monitoring personnel any hazardous or abnormality notification. So an increasing load imbalance may be detected, but is not the subject of any alarm to a monitor, and therefore none to an operating crew to at least ensure a visual inspection if the findings are below immediate set out. Is L.B. Foster's recommendation that every anomaly at or over 90 KIPS should be reported to a crew en route?
I believe every alert at 90 KIPS or over, I believe is reported to RailLink. Some 50,000 per month in the industry from wilds. With that said, if the owner of the wild is also the owner of the vehicle that issued a 90 KIP alert, it's up to them to decide whether or not they want to do anything about that. And so that's where we see a difference between, the AAR guidelines for reporting from wilds and then what, especially in the Class 1 industry, what owners are doing, right? They have the 90 KIP to authorize billbacks for other people's vehicles, but then they have their own set of thresholds that they use to maintain and monitor their own vehicles. And maybe they'll set out, maintain a 90 KIP wheel. Maybe they won't. I mean, there's a lot more with the data than just high impact that could inform a user whether or not this 90 KIP wheel is problematic. As an example, if you get 91 KIPs on both left and right wheels of a truck, it's most likely a wheel flat. And some agencies may be willing to let that go for now and favor a wheel that measured 95 KIPs on one side, but 40 on the other, because that's most likely something like shelling or spalling, which can grow in severity much more quickly. So there's a lot of sophistication that goes into that. Would I recommend reporting all 90 KIP impacts? Yes, to RailLink. But I think that there's a lot more to be said about whether every individual agency should immediately act on 90 KIP impacts.
Thank you. Are you collecting more data with the Wild 4 system as compared to the Wild 3? If so, what are your plans in utilizing the extra data?
We are, yes. The precision and the sampling rate are both improved. A lot of that's got to do with the processor being on the rail. And actually, right now, we're in development of an overhaul to the reporting format for the wild. And some people in the industry I may have shared this with already, but what we'd like to do is, instead of delivering just a single value, let's say you have a 120 KIP wheel, and we send you an email alert and we say this wheel measured 120 KIPs. It's not very informative. It just tells you there's something going on with this wheel. What we'd like to do in the future is, I mentioned we measure each wheel 16 times. If you get a wheel that measures 120 KIPs, we'd like to deliver all 16 load profile measurements to you So that way you could see the shape of them. You could see how many times this impact was measured throughout the length of the system. We'll provide information about all sort of metrics about each crib and how confident we are in that information. And then, the idea is we'd like to start correlating defects with load profiles so that we can start to predict the type of defect before you have to pull it to the shop.
Thank you. What is the procedure for changing out rail and ties at the Wild 4 site?
Well, a rail replacement will, as I've mentioned before, it will require what we call a disconnect reconnect. Generally, I guess you could call it a rebuild. The gauges will have to be replaced. The rest of the equipment can be taken off and disconnected. And then after the rail is replaced, reconnected. Tie replacement, I mean, I know that there are, kind of a lot of ways that you can replace ties. And so I generally wouldn't recommend trying to do tie replacement with the Wild installed. I would recommend a disconnect. I mean, you could see in the photo there, right, that the front end processor is sitting right above the rail clip. And so just the very act of removing rail clips, especially if it's, an E-clip style that you hammer on and off, you just run the risk of damaging the equipment. And so I would say for tie replacement as well, I'd recommend removing the Wild. But no need to remove and replace the gauges if you're just replacing the ties.
Thank you. You said that the Wild can extend wheel set lifespans. By how much and how is that achieved?
Yeah, good question. So that report from the FRA back in 2019, they were looking at Metro North Railroad, and Metro North reported that they saw by using a Wild to dictate wheel maintenance, their lifespan of their wheels went from 2.5 to 3 years. So that's a 20% increase. And in fact, that was back in 2018, 2019. I spoke with a retired engineer from Metro North in 2022 about this, and he had told me that by the time he left, which had been recently, that their lifespans were actually up to about 4 to 4.5 years. So that's an 80% increase in lifespan. And, that could be significant savings for an agency like Metro North with some 4,000, 5,000 wheel sets. Now, the way it's achieved is we're using the Wild, or they are using the Wild to dictate their maintenance regime, right? So as a public transit agency, maybe they inspected their wheels on a time interval every month or 2 weeks. Maybe they were doing it on a mileage system, right? Instead of doing that, they would use the Wild's report to indicate that a wheel needs to be inspected. And what happened is they were finding particularly wheel flats, but many defects much earlier. And when you true the wheel to maintain it, you could take off significantly less material, right? So whereas a wheel might have only survived two truings, now it could survive 4 or maybe even 5 truings. So that's where the extended lifespan is coming from.
Thank you. How many Wilds are installed outside of Class 1 networks?
So I can only speak for L.B. Foster's Wilds. We have some 215, 220 Wilds installed. About 70 of those are outside the Class 1 agencies. Some of those are still in kind of heavy freight applications, just not with a Class 1. But we have some 40 Wilds on regional, industrial, and short line railroads. And then we have 22 Wilds, I believe, on passenger systems, namely Amtrak. Of course, they, helped us with the invention of the Wild. So.
Okay, thanks, Jacob. This is the final question. What is the typical lifespan of a Wild?
Yeah, this one, it's really going to depend on operating conditions, right? And also how well the Wild and the track are maintained. But with that said, I mean, there are many Mark III, the previous versions of the Wild, that are out in service today that are, there are many that are 20 years old and more. There are a number that are 25 and 26 and 27 years old. And these are actually Mark IIs, the version before the Mark III. So with proper maintenance, I think a recommended lifespan or a good lifespan to promise by would be 15 years, maybe even 20 years. And under good conditions, it can be 25 years or more.